This brief presentation provides an overview of System Platform, detailing the components it's made up of and the advantages it provides. At a 30,000-foot view, System Platform can be described as a collection of software products that provide numerous functions to manufacturing and service-oriented industries. These functions include supervisory control, historization, as well as visualization and reporting, and of course data acquisition, the ability to retrieve data from a variety of controllers and devices, such as Siemens, GE, Modicon, Allen Bradley, Mitsubishi, Omron, Texas Instruments, Automation Direct, and many, many more. Let's start by taking a look at the foundation on which System Platform has been built, the product called Application Server. This product provides system designers with the ability to define all the related elements of an asset or a device, such as the I/O points that are associated with it, as well as any logic and scripts that may be needed for the supervisory system to interact with the device. It's also here, within the asset definition, that we identify what data points we want to store long-term for analysis. We can also define who can operate and interact with the device from within this definition, and that applies to both the runtime model as well as the development time or design time model. We also have the ability to configure the alarm limits for various data points associated with the device, and in the latest release of Application Server, we introduced the ability to store graphics associated with the device inside the template definition as well. Now, with that being said, it is important to point out that Application Server is not the visualization system. It's not an HMI. Rather, Application Server enables you to separate the logical execution of your supervisory system from the visual system while still containing those visual representations. That's one of the key benefits of Application Server, because by separating these functions, the supervision from the visualization, we're able to simplify the design of each component by focusing each on what it's supposed to do, not mixing them all together. And because they are separated from one another, we also realize a simplification in implementing, again because each component is focused on what it's supposed to do. And because these systems are separate, we're more easily able to maintain the system because changes in one does not necessitate a change in the other. Coupling these things together, the usable lifetime of the application is actually greatly extended. Now you might be wondering, how is it that things are simpler if I have two different systems to maintain? Well, with traditional HMIs, where the supervisory elements and the visual elements were defined within a single application, you had numerous areas where you had to define all kinds of things. For any one device, like a valve, you would create multiple data point definitions, oftentimes called tags. Then you would go somewhere else to create scripts, or the logical elements. And these logical elements would do things like evaluate I/O bits and words, set calculated values, things like that. Then you'd create windows and graphics and animate those graphics, and eventually you might even go to the historian and recreate the data points that you'd already defined in your HMI, and when you added another valve, you'd do it all over again, creating each of these elements by hand. And with Wonderware and products like InTouch, we tried to make this a little bit easier by enabling you to export your data definitions, modify them in Excel, and import the changes back in. And with our historian, we gave you the ability to do what we called delta imports, so your historian could simply reference the HMI to get its updated data definitions. But it boils down to this. This was mostly a manual process, and it was prone to error, specifically user error. It was easy to forget to update an animation link when you copied it from one graphic on one screen and pasted it in another. And this isn't a Wonderware thing. This is how most HMI systems worked. What Application Server enables you to do is separate the components that don't belong together and combine the ones that do. You see, with Application Server, you define a template that contains all this information, all the data points associated with the device, all the logic and scripting related to the device, all the alarms and limits, what should be stored in the historian, and even what graphics are associated with the device. All these things are contained within a template definition. And because these templates contain all the information necessary to define the device or asset, we realize significant reductions in the overall engineering effort, because you're not recreating the wheel every time you add another device or valve to the system. We also realize significant savings when it comes to making changes. Let's face it, oftentimes things change. For example, we may notice we're having a lot of valve failures during production, and in an effort to reduce the number of failures that occur, we decide to start measuring the amount of time it takes for a valve to transition from one position to another. This way, we can identify valves that are starting to fail and need rebuilt and schedule maintenance on them before they're used in production again. With the traditional system, this would require us to add the tags and the scripts associated with this ability into our HMI for every single valve. But with Application Server, we can simply modify our valve template, adding the necessary tags, logic, maybe even historizing some of the configuration points, and that change will then get propagated to every valve created from that template. So far, we've only focused on these templates that are relatively simple representations of our real-world devices. But another benefit of these application templates is how they can be combined to represent more complex devices and equipment. Here's an example of a brew kettle, which contains other templates for things like valves, pumps, motors, agitators, and a whole lot more. And this template is used to create instances that represent real-world equipment, like 2 brew kettles actually used in production. And if we need to add another brew kettle to the process, our supervisory system in HMI can be updated by simply right-clicking on the template and selecting New Instance. Also notice that there's an option to create a new derived template. This feature enables us to take an existing template. Maybe our brew kettle template was defined very generically with points that would be common to any type of brew kettle. Well, we can derive a new template and make it more specific to the brew kettles we're using in this operation as opposed to what they're using at a different facility. This powerful capability enables us to create templates that are generic and then derive templates to be more specific. Another way Application Server helps to reduce the overall engineering effort is with its powerful scripting engine. You see, Wonderware products are in over 100,000 plants worldwide, and because our products have been used in so many places, we understand a lot of time and effort has been put into scripting and the logic of our traditional products like InTouch. While Application Server continues to support those scripts, at the same time, we also recognize that people want to do new and more complicated things all the time. And in order to support that, we need to support the use of new technologies within our products. To meet this need, Wonderware designed Application Server to not only support the use of our traditional scripting engine, syntax, and functions, but we also added the ability to use Microsoft.NET functions directly within this product. By doing so, we've greatly expanded the ability and capability of the supervisory system to interact with other external systems like MES, ERP, LIMS, and lab systems, database applications, and a whole lot more. Finally, we'll wrap up our review of this foundation product by looking at its scalability. You see, when you create instances from your templates, you also tell the system where these instances will be running or executing. It might be an HMI node or it might be a server without any HMI at all. The key here is that you decide where those elements will be executing their data acquisition, their scripting routines, their historization logic, and all that. If one machine happens to get overloaded with too much, you simply drag and drop the objects you want to another node. The amazing thing about doing this is it actually doesn't impact any of the other components on the system. With traditional systems, you would have had to modify the data definition in your HMI so that it would point to the correct place, telling them where to go to get the data. But Application Server utilizes what's called a common communication namespace. It's a fancy way of saying you don't need to know where the data's at, it can go find it, you just need to know what you want to ask for. So if I were to move my Brew Kettle 100 from one PC to another, I don't have to update my HMI applications, they automatically know where to look to get the data from the new machine. Of course, Wonderware uses its most famous product, InTouch, as a visualization component. InTouch continues to offer process visualization and control, alarm and event enunciation, trending, and a whole lot more. However, InTouch has one dramatic update. It can now utilize the graphics created within Application Server, and these new graphics have some significant advantages. Probably the most significant difference is what these graphics actually contain. Not only are they visual elements drawn and animated, but these graphics also contain their own data point definitions and scripts. So they behave like mini applications, and you no longer need to mix animation enhancing scripts with your supervisory logic or even with the window logic of your HMI. These graphics contain their own scripts as well as their own data points. This enables us to create really good looking graphics that are generic enough to be used in virtually any application. So a meter that is used in one app can easily be reused in another, and the creation of these custom points doesn't require additional licensing or tags. While I'd like to camp out here for quite a while detailing how these graphics can be designed and used to greatly simplify application development, it's time we move on to our next component of System Platform, the Wonderware Historian. The Historian product is Microsoft SQL based and actually extends the capabilities of SQL Server. It can log tremendous amounts of data over long periods of time, and it compresses the historized data with a lossless algorithm to ensure you can store a lot of data over a lot of time in the least amount of space and not lose anything while compressing it. Data is acquired in one of two ways by our historian. It's either polled or pushed. Polled data is the model most historians use, where you define what data you want, and then the historian periodically goes out and retrieves that. Wonderware's historian also supports the ability to have remote systems push data into the historian, and this happens to be the model Application Server uses. With this architecture, data is acquired from field devices on a remote node, and then pushed back to the historian. There are two benefits to this type of architecture. First, historians typically require server-grade hardware and operating systems, and are oftentimes located within environmentally controlled server rooms. Unfortunately, these server rooms are rarely anywhere near the field devices, so the potential for network disconnects is usually pretty high. By having a remote node query the controller for data, however, we're able to do this from an environment that's literally physically closer to the actual device, and oftentimes this reduces the potential for network disruptions. However, what happens to the data if the remote node can't communicate with the historian to push the data back across the line? Well, with the Wonderware's historian, it's cached locally on that remote node until the historian is available again. When the connection is reestablished, live data, as well as the cache data, are sent to the historian for storage. And if the server happens to be busy, it may not want to accept the cache data right away. That's okay. The remote nodes will try, wait a while, try again, until all that data can be pushed through. And once it's been forwarded, the local cache is removed. This powerful data logging architecture helps ensure data is not lost, and it's what we call store and forward. Finally, there's the topic of data retrieval, and let's face it, stored data is completely worthless if you can't get the data out of the system. Well, Wonderware's historian supports any client application that is SQL compliant, and you retrieve the data exactly like you would from any other database. So, if your organization is accustomed to using some proprietary application for analyzing data, you can continue to use it as long as it communicates with SQL. And unlike traditional databases, extracting time series data is considerably easier with Historian. We've provided numerous functions that make the retrieval of time series data much easier, like built-in pivot tables and data interpolation. Wonderware also provides a number of different reporting tools for analyzing the data as well, the first being our Active Factory client tools. Active Factory consists of a time-based trending tool, Microsoft Word and Excel plugins, and a query tool for those of us that aren't exactly SQL gods. These tools enable users to quickly access and analyze the data stored within the historian. Additionally, each of these tools enables you to save your report or custom configuration for later analysis, and even to publish what you've created to a website, specifically Wonderware's Information Server portal. Information Server is a web-based portal providing access to a variety of data, including historically logged data, live data, alarm and event information, and even custom reports. While it provides web-based access to all this data, it does so in a way that does not require you to have web developers on staff. All configuration of the portal can be done within the website or the portal itself, and again, does not require any web page development. Live and historical data can be accessed through a number of different ways. Pre-built reports from sources like when you install the product or from third parties, or even through InTouch windows that can be published to the site. Alarm and event data is accessed very similarly, and is a great way when you combine these two to expose real-time information to management-level personnel without requiring them to run a full HMI client on their business systems. Information Server also provides numerous reporting options, including 3 distinct reporting engines. Table Weaver is a reporting system created by Wonderware that enables you to both author your reports and view the reports within the website. For more complex reporting capabilities, we also support the use of SQL Server reporting services, and we provide some example reports with the portal itself. And finally, as was mentioned just a moment ago, reports created with our Active Factory client tools can also be published to the Information Server portal. We hope this very brief review of System Platform was valuable and provided you with the information you were looking for. If you have any questions or would like to talk about any of these products and their capabilities further, please contact your local Wonderware representative.